Alright, this is the review for the Chapter 6 test that's coming up this next week, and we'll go ahead and get started here. Now, the first thing we need to talk about is the vocabulary. You have a pretty long list on there. You need to go over these on your own. You can look them up in the back of your book, and then you should already have them actually written down in the glossary inside your science notebook. Recommend that you stay with a friend or a family member. Make sure you know the definitions and also how to actually use those words. Remember, the test is going to be more than just saying the stuff back to me. It's actually going to be using this information and applying it to more situations. Now, we'll go ahead and start on the concepts. The first concept that was listed is what air is made up of. Remember, it's 78% nitrogen, 21% oxygen, and 1% other gases. We actually saw this exact same graph as we're going through the experiments in the lab, and then also in the last quiz review. And you can see on here it shows that the argon is 1%. The other gases make up just less than 1/10 of a percent, nitrogen 78%, and 21% oxygen. Now, this all plays into the part of what's called air pressure, and the next concept is how air pressure works and affects the atmosphere. When we take a look at it, force from the weight of the air pressing down on us, or down on an area, is called the air pressure. Normally we think of it in terms of like pounds per square inch. That's one of the units. And it's just as it says, it's how many pounds are sitting on 1 square inch. And we know that the atmospheric pressure is about 14.4 pounds per square inch. Now, density helps to drive this pressure, okay? And so the more particles in an area, the higher the density is, and therefore the higher the pressure. And this makes sense. It's kind of like if I was to talk about filling up a box. If I was going to try to put 10 pennies into a box versus 1,000 pennies into a box, one is more dense, and you would agree with it. It also would have more pressure. So I would say drop it on you or have it sitting in on your hand. One would feel heavier than the other, and it would have more pressure because it would be pressing down on you. And this also then plays into effect of the altitude in the atmosphere. As we increase the altitude, we actually have decreasing pressure. As you go up higher, there's actually less stuff pushing down. And again, this makes sense. It's just like if you were thinking about trying to climb up to the top of a mountain, there's going to be less air up there. But you kind of experience a similar, but somewhat different at the same time phenomena when you say dive down low or down deep inside of a pool. As you get down lower, you probably feel your ears feel like they're being pushed in a little bit, or when you're riding an airplane, your ears feel like they're being popped out a little bit. Those are both because of the increasing and decreasing pressures because of where you're at. Down deeper, greater pressure; up higher, lower pressure. The next topic is how energy is transferred from the sun to the earth. We saw this was in the form of electromagnetic radiation, specifically the form of infrared radiation. Infrared radiation will then heat up surfaces and cause several other things to occur, which we'll talk about when we look at the greenhouse effect and how it heats up the surface of the earth. But specifically, the infrared radiation coming from the sun is what causes us to have the energy being transferred. Of course, there's also the visible light and the ultraviolet light coming from the sun, but those don't actually transferring very much heat. They're transferring in other parts of the electromagnetic spectrum that are at a higher energy. Now, when we talk about the layers of the atmosphere, it's important to understand how they are classified. And I actually have a picture here and talk about it. They're classified according to temperature. If you take a look at the graph here, you can see that the troposphere has a pretty steady slope as it decreases the temperature as you go higher in the atmosphere. Then the stratosphere, it actually starts to increase back up until we see a peak form between the stratosphere and the mesosphere. That peak or flat area that you can see at the very top there is actually the spot that we define as being the separation between the two different layers. We can then see it again occur for the mesosphere and the thermosphere. So these characteristics are very important when we take a look at trying to figure out where the different layers are at. And if you think back to when we did the trading cards, you remember that the troposphere, they actually get a range for where it's typically or how thick it is. And that's because of this temperature. What we're looking for is when the temperature changes direction. When does it stop getting colder and start getting warmer again? That's the point where we have a new layer. The next part is looking at the order of the layers from the Earth's surface. Just like last time, it's troposphere, stratosphere, mesosphere, and thermosphere. It's also important to remember, though, the thermosphere can actually be split into two different layers, the ionosphere and the exosphere. Now, of course, you know the troposphere is where the transfer or the movement of the atmosphere occurs the most. That's the part where the weather typically occurs. And then also the stratosphere is where the ozone layer is found at. next part is talking about what causes winds. Winds are actually caused by air pressures from unequal heating. We saw that the surface of the Earth heats up differently. We did the heating of the Earth's surface lab where we looked at dirt, sand, and water. We saw that sand heated up the fastest while water heated up the slowest. And this causes it to have a little bit different heating. You can also remember from back when we talked about seasons. I know this is a while back. It was probably 6th grade for you guys. When we talk about seasons, we talk about the unequal heating of the Earth's surface. Because remember, the sun actually does not hit the same, or does not dump the same amount of energy on all parts of the surface of the Earth because it's curved and there's the tilt of the axis. Now, these different pressures or unequal heating causes us to have high pressure areas and low pressure areas. Now, high pressure always goes to a lower pressure. The high pressure would be something that's more dense. If it's more dense, then obviously it's going to be a cold substance. And then if it's a warmer area, it's going to usually have a lower density, which also means that it has a lower pressure. It's going to be rising, so giving us those areas. Now, when we talk about wind, it's also important to understand which way the wind blows. Now, I know it seems like a weird concept to say, but you have to think about how we actually name breezes. For example, a north breeze means it's coming from the north. We're not actually saying where it's going, we're actually saying where it's coming from. Same thing for an east wind. It's going from the east. You can also think about it in terms of the what I said in class, or if you would say run into the principal and he asks you where are you coming, or where are you going, or what is your direction. If you were a wind, you would respond, I am coming from science, or I am a science breeze, saying where you're coming from. That's actually one part of how we describe wind. There's actually two characteristics that describe wind. There's also what's called the speed. Now, that's measured with an anemometer. We looked at one of those in class. Basically just catches the wind and sees how fast it's moving. When we know the speed and the direction, we can actually define all the information we need to know about a wind or a breeze. Now, when we're talking about winds and breezes, there's also a difference between how big they are. So the next concept is, what is the difference between a global wind and a local wind? A global wind occurs over a long distance. We're talking about hundreds of miles of distance. While a local wind can happen just over a very short area. You can even just have a local wind occur for, let's say, at a lake cottage. You have probably experienced this. You stand in front of a lake cottage right by the lake, and you can feel a nice breeze going there. That is a local wind. It's not going to be happening across the entire state or even across the entire county. It's just in that one little area. Now, when we take a look at the wind belts here, this is a slightly different graphic than we have in the book. We filled this in class as well. You can see up at the very north and south pole, we have the easterlies. They're actually called the polar easterlies. And then down at the 30 degrees north and 30 degrees south, we have the horse latitudes. From the horse latitudes, we actually can see that the wind blows away towards the pole or towards the equator, and that's from the falling air that occurs at the horse latitude. At the horse latitude, the air is always coming back down to the surface. When we go down to the equator, we actually have the air rising up from the surface, causing what's called the doldrums. And since it's rising back up, the trade winds come in, and they causes it to go back up again, because also, remember, it's warm at the equator, it's cold at the poles, and so it makes sense. Cold air sinks, warm air rises, densities change, pressures change, and we get these formations of the winds. And remember, the trade winds, an easy way to remember them is you think about back in history. You guys have talked about this in social studies, I'm sure, that there was trade routes that always ran across the ocean. They caught these trade winds in order to get them to move across, because you had a nice big temperature difference, which means you're going to have a nice big breeze going there. A very important thing to make sure that you have a good grasp on that. Now, the next one is how to describe winds and identify where it is likely to come from. We've already talked about how we describe which direction they are. The next thing, though, is understand when do they occur, and then how to know which direction it's going to be. And so we want to talk about the idea of what's called a sea breeze and a land breeze. We just talked about this in class, and here's another picture showing it. You can see during the daytime we have what's called a sea breeze. What's happening is the land, as we saw in heating Earth's surface, heats up much faster than the water does. And so since it heats up much faster, it's going to have warmer air above the ground, because the ground is going to help warm the air up, and the air is going to rise up higher in the atmosphere. As it gets up higher in the atmosphere, as we've seen, it cools down. and so and at that point it's moving over above the water. When it rises up, it leaves an empty spot or a lower pressure spot. Of course, the air over the water is colder. If it's cooler, it's going to have higher pressure, and so it's going to move from that high pressure to the lower pressure, so we can see these breezes happen. Now, at night, when we have a sea breeze, or a land breeze, we actually see the whole process reverse. And this makes sense when we think about it. Remember, the water is actually going to stay warmer longer, because if it takes longer to warm up, it's actually going to take a long time for it to cool back down. Think about it like an aluminum pan. It heats up really fast, well, it cools down really fast too. It's the same situation for water and every other substance. However fast it happens the same for the other direction. And so we can see here that the land cools down faster, gets more dense, while it's warmer out over the water. And so we have the cool breeze moving across the land out and back into the water again. The last concept we need to talk about is what the greenhouse effect is and how it affects us. We take a look here at this picture. Again, this is a slightly different picture from what we looked at in class, but it covers the same stuff. We see that solar radiation comes from the sun. It helps heat the Earth up. When the radiation comes to Earth, it's either reflected or refracted, or it's absorbed. All right, and so what we can actually see is a lot of it, or about half, it's absorbed by the Earth's surface and warms up the surface. Now, of course, if it's warmed up the surface, it actually radiates heat out, and like on a hot summer day, you actually see those heat waves forming off in the distance. That's from the radiation coming from the Earth's surface. And what happens is it gets trapped in what's called the greenhouse effect. And basically what happens is it warms up gases, and those gases help reflect the heat back down. Now, there's a lot of controversy of saying that it's not a good thing, but the greenhouse effect does have an impact on our lives. And if it wasn't here, we've seen that we'd actually have some major problems. So it's very important for us to have this greenhouse effect, even though we definitely want to make sure we keep it in check at the same time and not have too much of an effect from it. Trying to keep warming the Earth's surface, otherwise we may become like the planet Venus, which has a runaway greenhouse effect occurring on it. And so there's a very interesting fine balance on that, making sure that the greenhouse effect is there, but at the same time we don't want it to become overbearing. But as you can see here, basically what happens is the light or the energy gets trapped on the Earth's surface. Some of it still escapes out, some of it still makes its way out, but a large amount of it, at least 50%, is hitting the Earth's surface and staying here. So this wraps up the Chapter 6 review. I know you're thinking right now, oh, Mr. Corey said you're going to tell us the answers to the questions at the end of the chapter review. I am, but you're going to have to wait until Monday in order to get those. So have a good weekend, good luck studying, and enjoy 60s week.